Welcome, y'all. I'm the Longship Medic. For today's episode, I want to introduce you to a new series that I've been working on. I want to present the cutting edge of military innovation for everyone. So what I'm going to be doing is I'm going to be breaking down a recently published article that has a basis in military medicine of some kind. Today, we have an article out of the Journal of Military Medicine. Its title is A Wearable Multimodal Vital Sign Detection and Photobiomodulation Device for Early Brain Injury Treatment, a Feasibility Study. That was a mouthful. Okay, my background, I love a good feasibility study. It means they have the science, so let's see if it'll even work. Chef's kiss. So, what's their concern? First, let's talk about the numbers. This article cites that only a quarter of evacuated warfighters even get pulse ox checked. I mean, I can, to some degree, understand that and wrap my head around how that might happen, but the author cited another paper for those numbers. In this paper, titled Battlefield Vital Sign Monitoring in Role 1 Military Treatment Facilities, a Thematic Analysis of After-Action Reviews from the Pre-Hospital Trauma Registry. Jeez, with these titles. In this article, they originally pulled from a group of 737 registered encounters that had been evacuated between January 2013 and September 2014. However, of those, only 86 were selected for after-action review analysis. Now, scientifically, that's a good thing, to an extent. You might say, well, that's only 86 evacuees in this relatively short timeline. And you're right. But from another perspective, they had really strict requirements for their inclusion criteria. This cuts down on extraneous variables and gives you the ability to say with some confidence that A appears to lead to B. If you just threw everything into a pile and found a result, you wouldn't be able to say what caused it with any real certainty. So, of this population of 86 evacuees, 24%, or 21 patients, had some level of pulse oximetry data. 41%, or 35 patients, described heart rate, and most common were blood pressures, which made up 62%, or 53 patients out of the cohort. They also added BP by palpation, which I love. Sometimes it's the best you can do. I'll definitely do a follow-up episode with a little bit of information on this technique and the science behind it, but I digress. Anyways, here's where this can be construed as slightly misleading. If you read the first article, they simply state that among urgently evacuated warfighters, only 24% had pulse oximetry checked, 41% heart rate, and 2% temperature. Now, that last one made me chuckle a little bit. Extremely important, but I just picture my silver bullet being at the bottom of my bag and how hard the insertion point can be to get to, if you know what I mean. But in all seriousness, this is where critical thinking comes in. I have the numbers in front of me, and so I have to think, do I still think this is a considerable issue? Yes. Do I think it's hard to find specific studies or AARs with all of the information needed? Also, yes. Honestly, I wouldn't be surprised if they somehow magically gathered all of the AARs in OIF and OEF and found that the percentages were significantly lower. But the beauty of it is that you get to make up your own mind. From my experience, I know how hard it is to conduct regular monitoring of vitals and having to consider other things such as, returning fire, moving patients, and working with a team that has minimal medical training. Somebody once told me. And honestly has other things to worry about. So let's get back into the article a little bit. This team tested a prototype from Hero Medical Technologies that is basically a forehead-mounted wearable sensor paired with a mobile app. You can see it here. The wearable uses photoplethysmography. The wearable uses photoplethysmography. Photoplethysmography. The wearable uses photoplethysmography. The wearable uses photoplethysmography which is the same principle as pulse ox currently uses. It also uses infrared to track pulse, oxygen, saturation, and skin temperature. The app then uses the phone's camera for additional vitals such as respiratory rate and even pain detection through facial analytics. Here's where it gets cool. The idea is that in the future, if the device detects low oxygen, high heart rate, or severe signs of pain, which are all secondary symptoms of TBI, it will automatically trigger photobiomodulation, which in this case is red light therapy, through quantum dot LEDs built into the dressing itself. That part wasn't tested in this article. For now, the red alert light just was simulated, but the vision is real-time monitoring plus instant therapy in the field. And that's the dream, right? But I have to geek out for just a second. So let's dive into this technology for just a little bit. So how does this even work? Red and near infrared light can actually change how your cells behave. At the mitochondrial level, the light hits an enzyme called cytochrome C oxidase. Think of it as the spark plug of your energy system. That little boost ramps up ATP production, calms down inflammation, and helps stress or injured cells survive. That's photobiomodulation, or PBM. Now, where do the quantum dots come in? So, normal LEDs spray out a wide spectrum of light, like a shotgun blast. Quantum dots, on the other hand, are nanocrystals that can be fine-tuned to fire exactly the wavelength that you want. That means if your target tissue responds best to, say, 665 or 810 nanometers of light, the QD LEDs can lock in right there. No wasted energy, no off-target junk, and because they're tiny and flexible, you can embed them directly into the head dressing. So imagine the medic slaps this dressing right on the casualty. The sensors detect low oxygen or dropping blood pressure, and bam, the quantum dot LEDs switch on, delivering red light therapy right there in the field. Continuous monitoring plus automatic treatment. The authors of this study aren't quite there yet, according to this article. They simulated the red light with alerts, but the QLED integration is what's coming next. They do cite work that has shown how quantum dot LEDs can deliver high purity red and near IR light for optimized medical use. So this study was also small. 28 healthy volunteers ages 19 to 55. They ran through a mock triage workflow, tests such as breath holds, ice bucket challenges, and jumping jacks, while their vitals were being compared to the gold standard of devices that are currently used in the field. Their device showed decent pulse detection, but slipped in darker skin tones. Up to 39% of readings were undetectable. That's a huge limitation they'll need to address before full-scale implementation. Oxygen saturation was actually within about 1% error on average, which is really promising. Respiratory rate from the camera was a little messy. It often thought people were tachypnic just because of background movement. Pain detection with facial analytics looked great on paper, providing a cited 93% accuracy, but with real video, data was less reliable. And the machine learning models, when trained on big retrospective datasets like the National EMS Registry, they looked amazing. 98% accuracy for hypotension is huge. 93% for pain, but when applied live in a chaotic real-world environment, performance really dropped off, which is the classic medical device problem we run into. It works great in the lab and stumbles in the wild. So what's our takeaway? This is early, but it's exciting. They proved the concept and have identified the next step. Wearables plus AI can continuously monitor vitals in a simulated triage environment. And a future add-on of light therapy could change the game for TBIs, especially in prolonged field care where evacuation takes hours, not minutes or seconds. Are we ready to put these into our next generation of Halo helmets? Unfortunately, no. Right now, they're still fighting the usual battles of sensor accuracy and diverse populations, environmental noise, and the gap between the lab and a live deployment. From my experience, anything that automates monitoring is a huge win. Because when you're out treating a casualty and also taking fire, you can't be staring at a pulse ox screen every 30 seconds. To wrap this episode up, this study doesn't give us the finished product, but it does give us a possible way forward. If they solve the accuracy issues and integrate photobiomodulation safely, we're talking about a device that not only monitors but treats symptoms of TBI in real time. That's the kind of innovation that I want to cover on this channel, and that's the kind of innovation that military medicine needs. And that's why I love feasibility studies. Did it work? But that is translational science at work. Much better to find out here than in the middle of nowhere. All right, y'all. That's it for today. If you have any questions or comments, let me know below. If you're interested in the tech or science behind this article, I have cited them down in the description. And if you like this kind of deep dive into cutting edge science, hit the like and subscribe for more. I'm the Longship Medic. See y'all next time.